So this is how I spent last 8 months building an entire software from scratch with a full-time job as an analyst. All because my boss couldn't run a Python script. And the wildest part, all started with one simple question. Hey, can you write me a Python script that takes care of this whole task for me? Sure. It was a simple analytics task, some group stat, a chart or two. I had written it in Python, tossed it into a clean Py file. I thought my job is done here. God forbid man have good time. Hey, it says I don't have the right version of NumPy and it's asking me to install something called polars. And there it was. The classic works on my machine syndrome. My script uses a specific version of NumPy, but my boss's machine had an older version of it, and to run a fast query on CSV, I used polars. But his machine have never heard of it, leading to an import error. This was supposed to be a 5-minute job. Just run the script, get the output, and you are done. I was no longer a data analyst. This wasn't just an inconvenience, it was a fundamental flaw in how we were sharing data workflows. And there was the moment right there when I realized I needed to rethink this workflow. I just wanted to build with block. If you grew up in late 90s, first thought about data analysis probably Excel. Yeah, the age-old Excel. It is simple, works the way you want it to, can do complex stuff and visualize data as well. Honestly, building complex stuff with Excel feels like organizing your life with folders. Works until it doesn't. I wanted something cleaner, smarter, and actually fun to use. Back in January, I really started looking through all my options. I did what every sane person would do after 2023. Ask ChatGPT about it. And I got few options. KNIME, Orange, Alteryx, Tkinter. I was very clear. I wanted a tool where I could visually assemble workflows, like snapping together Legos, not writing endless scripts. So I settled on a few options: KNIME, Orange, and Alteryx. KNIME. My first impression was intimidating. The interface was a canvas surrounded by hundreds of nodes tucked away in tiny folders. To do something as basic as reading CSV, I had to navigate different menus and get a CSV reader. Then I realized I needed a completely different node just to read a JSON file. Why can't they be in a single node? The power was clearly there, but the learning curve felt like a vertical cliff. I needed a manual just to open a file. Orange was slick and academically popular. I dropped my dataset in and immediately it was nudging me towards classification model and clustering algorithms. It's brilliant if you are doing machine learning exploration, but for my task, data transformation and reporting, it felt like using a Formula 1 car to go grocery shopping. It was, let's just say, overkill, and the tools for simple data wrangling felt like an afterthought. Alteryx was the closest I came to finding the one. The first time I connected data input to a filter node and it just runs, it was a genuine wow moment. But then I tried to do something slightly custom, like a specific string transformation using Python function. The process was clunky. Even though I enjoyed it, after a while, things got sticky. Can't customize this, can't extend that. Also, enterprise license? Okay, I don't have that kind of money. What I really wanted was the clarity of Alteryx with the control of Python, without the pain of setting up Python environments that breaks every other project. So I decided to take things into my own hand and slowly started working on my own piece of analysis and reporting software. This journey hasn't been without its ups and downs, from thinking how I go about sorting nodes, executing code, to rebuilding the program from scratch more than once due to lack of knowledge and technical limitations. I'm here to walk you through all of that. Over the past few months, gone from a simple Python script connected Pandas operation to a full-blown visual editor with trackable nodes, live output, and real execution. I started with just a basic idea: a node-based editor that is built in Python, drag blocks around and process data. Simple, except not at all. Let's talk from the start. Version 1 wasn't even a real app. It was more like me improvising in Python. I hardwired a handful of Pandas operation, printed out some results, and clubbed everything together with if statement. Fast forward to 2 days, I had about 800 or so line of spaghetti code, no UI, no idea how any of it worked anymore. So I moved to the next step. GUI hell, a short and painful adventure, because nothing solves a Tangle backend like throwing a new frontend on top of it. I had never really built up UI in Python, so I did what any developer with poor impulse control would do. I started trying everything. Tkinter, it's built in, it works, kind of. I threw together a quick window, added a couple of buttons, and yeah, within 10 minutes, it looked like something from 1998. And add custom widgets, hacky, drag and drop canvas, not happening anytime soon. Tkinter was like, it's fine for tiny stuff, but the moment you try to do anything dynamic, it collapses like a house of cards. looked promising. It's modern, cross-platform, touch-friendly. And then I tried it. Everything felt over-engineered, the layout system was weird, and the documentation not terrible, just confusing enough to make you start over every 15 minutes. DearPyGui. Honestly, pretty cool. Very fast, hardware accelerated, immediate mode GUI, but there are not enough resources. What I think is great for dashboard or utilities. Electron plus Python. I flirted with the idea of building a web UI. I ghosted it immediately. Mixing JavaScript with Python for something I plan to use offline. That's how you end up with a 1 GB installer and a pile of regret. After trying Tkinter, Kivy and others, I landed on PyQt. The reason wasn't just it looked nice, it was because of one of the critical components, the QGraphicsScene. Think of it this way, to build a node editor, you need a canvas that understands the object. When a user drags a node, the canvas needs to know where the object is, where its connection points are, and how to draw lines between them. With other libraries, I would have to do all of that manually. With PyQt's QGraphicsScene, it handles all of it for you. Not perfect, but it checked the right boxes. Native look and feel, check. Good drag and drop support, check. Can handle complex graphics, check. Actually well documented. Cross-platform, works on Windows, Mac and Linux. The learning curve, brutal at first, signal, slot, weird pointer things. It felt like I was talking to a UI system with C++. But once it clicked, it clicked. Here is the thing, I didn't figure this out on my own. Huge shout out to this YouTube series by Pavel. This series walks you through building full node editor from scratch with PyQt. I followed along video by video, slowly mutating into something that actually fit my use case. Added my system to access different part of nodes, different zoom functionalities, and so on. Data, the actual point of this tool. I knew from the beginning this tool had to be Python first, so naturally I started where most of us start. Pandas is basically Excel of Python. You can filter, group, sort, clean, all the usual stuff. It's great. Also kind of a mess. Some function mutate in place, other return copies, some accept column names. Here is the thing, Pandas is familiar. I use it almost every day. Everyone else does too. So it made sense for me to use it as a default engine. At some point, I hit the bottleneck with Pandas. The performance just wasn't cutting it, especially when chaining together multiple transformations on a large CSV. It's fast. Plus, the syntax is cleaner, it doesn't mutate in place, it encourages method chaining, it's made for modern machine and big data. But here is the catch. Polars isn't Pandas. The APIs are different, the ecosystem is smaller, and you can't just drop in df column sum and expect it to behave the same way. So I kept it around, but more as an optional engine like the performance mode you toggle on when it really matters. Then came DuckDB and everything changed. DuckDB lets you write SQL directly on top of your data frame, even in-memory pandas or Parquet file, even on Polar's data frame. And it's fast, shockingly fast. Here is what's mind-blowing. Select category, average price from data frame, group by category. That's it. No group by, no aggregation, just plain readable SQL. You don't need to spin up a database or configure anything. DuckDB just runs in process, in memory, no drama. So I added support for SQL as well in Trigger, powered by entirely DuckDB. Great for people who think in SQL and a perfect complement to Pandas and Polars. And you heard it right, I named it Trigger. Why? I don't know. It sounds cool. So what did I end up using? At the end of all of that, I settled on a trio. Pandas, standard everyday stuff, Polars for big fast data pipelines, DuckDB when SQL is the better language for the job. The UI has two main areas that makes it usable and actually pretty fun to use. Top ribbon, think of it like node palette. You have got categories. You can drop any node into the canvas from the top bar. It's fast, smooth and very click and drag friendly. Side panel, this one is important. When you click on the node, the left hand sidebar shows all its options. Want to change which column to keep or set a filter condition or tweak the formula expression? You can do it here. The other feature is node search. You can just press shift A into the canvas to search for nodes, similar to how Blender does it. Themes currently supports light and dark theme. Socket output. Alt click on any socket to see the data output for that particular socket. Zoom in, zoom out, fit to screen, all the usual stuff as well. Okay, but what's missing then? Look, as proud as I am of this work, there is still a lot on the I'll build it soon I swear list. Here is what's missing or half baked right now. Undo/redo. Yeah, it's 2025 and I still haven't built Control Z. I know, but it's a node editor. Every action, moving a node, creating a connection, changing a filter setting, It's complex state change. To enable Ctrl Z, I needed to implement something called command palette. Every action has to be a command object that knows how to do itself and more importantly, how to undo itself. It's a significant architectural change, but it's on top of my list. Copy paste node. It's kind of working, but not there yet. Alright, I have picked the UI, the engine under the hood. Now it's time to make things really do stuff. Input read CSV, Excel, JSON, one input node to rule them all. Only select columns you need, no need to clog your RAM with full data frame. Filter, think of it like SQL but with way less headaches. Sort, ascending, descending, even supports multi-column sorting. Join, left, right, inner, get all of it in a single node. Unique, drop duplicates without the guesswork. Formula tool, supports custom math or logic, both Python and SQL. Output, dump the result to a CSV or an Excel. These are the bread and butter of ETL pipeline and they are all there, almost fully functional, previewable and executable. Basically, Trigger right now is like a sharp, well-made belt missing few tools. It's already useful but I know it's not complete. But the best part, it's mine, built for me and maybe you. It is an Alteryx competitor? No, that's not the point. The point is that it works for me, solves the exact problem I had, it's flexible, it's fast and doesn't judge me when I forgot how group by works. And I can keep shipping it however I want. Add new nodes, try weird ideas, tear it apart and rebuild it from scratch, which I have already done twice. Alright, that just wraps up the deep dive into my very niche, possibly over-engineered node editor journey. Honestly, I am very amazed at how a so-called simple workflow problem can turn into an entire side project. Here we are. Make sure to subscribe so you don't miss what's coming next. Oh, and if anyone else suddenly gets a boss asking them to pimp up a Python script, maybe send them this video before saying yes.